Welcome everybody for another episode of Wireless Works, sponsored by Cambium Networks. My name is Daran Hermans. I'm your host and your guide. Today we're joined by Mitchell Parsons. I'm glad that Mitch came back, joined us again to record another webcast on this topic of Wi-Fi 6E. Mitch, give us a quick introduction for those people who haven't met you before. What do you do at Cambium, Mitch?
Well, my title is a technical product manager, but really what that means is that I cover all the gambits of what Cambium does, whether it be the 28 gigahertz, the 60 gigahertz wireless, the Wi-Fi, the switching and routing. So I really kind of cover every one of our products in detail and the utilization and use.
All right. Well, you're a hard guy to get a hold of, Mitch, because of that scope of work that you do at Cambium. So I'm glad you gave us some of your time. We'll make the best use of your time here today. So very grateful to have you here and talk about this topic. So we talk about Wi-Fi 6, Wi-Fi 6E. That's going to be the topic of the day. One of the things that people often get concerned about is they kind of throw their hands up and go, "Oh, geez, this is another technology. This is another technology I have to deal with." I thought we just went through this. I thought we just went through an upgrade a couple of years ago. And it does seem that way. It seems like the upgrade cycles and technology cycles are coming rapidly. So what's happening in terms of these upgrade cycles, Mitch? What's going on here?
I mean, we get improvements each and every time we have an upgrade. We have an improvement. So you started off in 802.11b, right? We had a 2.4 network. Clients had very low throughput, but I mean it was functional, right? It provided some use. But then we kind of said, hey, we need more bandwidth, right? We always want more power, to quote one of my favorite comedians. So we come out with the G standard, right? So we got a little bit more out of that 2.4, a little bit more throughput. We had to be backward compatible for the B, so that kind of dragged us down a little bit, right? So we said, okay, we don't like that. We don't like being dragged down. What we can do? Well, hey, let's move to a different frequency. And so we come up with 802.11a, and we open up the 5 gigahertz band for that. And that was rocking along pretty well, right? But again, what happens? Our users want more power. They want to be able to do more throughput. We start streaming video, we start watching YouTube and Netflix and stuff like that. And so we say, ooh, okay, well, we're limiting ourselves. So let's come out with the next standard. Well, we said, well, what can we do? Well, how about we bond some channels together and give us a wider bandwidth, right? So 802.11n, right? So we had that quick jump. Mm-hmm. Well, and we like that channel bonding, but it really just wasn't quite working the way we wanted to. So then we said, well, what if we could do contiguous channels with the same capability? And so we come up with this whole thing of like, okay, well, that 5 gigahertz, right? We got a lot of frequencies there. So we said, hey, why don't we come up with 802.11 AC? And so now we have, 80 gigahertz channels and 100, and in some cases you can kind of get up to 160 gigahertz channels on some equipment. But we went from a 20 megahertz to a 40 megahertz to now an 80 megahertz, right? So now we're putting more through, right? And so we allowed for clients to be able to multiple clients receive broadcasts, but we're still kind of limited in that AC where it's kind of a 101 up, right? So, well, wow, everybody wants everything wireless. Wireless is almost like air and water, where, if I don't have air and water, I'm not alive. So I need something more. So now we've come up with this 802.11ax that kind of solves those contention problems that we had in AC. And then in turn, utilize that 5 gigahertz band even better with more protocol standards on top of it.
So I really liked the 11AC part of that cycle myself. It worked very well. As you mentioned, channel bonding, but also brought in some other new things. Another jump in the QAM up to 256 QAM, which gave us a 30% improvement on how densely we can pack the bits per symbol. So we jumped up 30% in our bandwidth just right off the top with that. But also 11AC did a lot of nice work around a standardized transmit beamforming. So now we have a standardized way of doing it instead of proprietary ways. And so there's more control now over transmit beamforming. And that technology has just, has replicated through all 11AC technologies and generations. And that standardized transmit beamforming continues on into Wi-Fi 6 and 6E. That was a big boost by getting to that standardized way of doing beamforming. 11AC also did a nice thing with packet aggregation. So we're taking all those small response packets and acknowledgments or not acknowledgement, NACs or NACs and ACs, and combining them, right? Combining them together and then being able to transmit a whole bunch of data and then let the client respond back to the bulk data instead of responding to each packet. So that improved 11AC quite a bit. There was a big jump. So why, so let's talk about this jump, the next jump, right? The one that we just went through, or I say we're going through it right now, which is 802.11ax. If 11AC is so good, it's got all this transmit beamforming, it's got wide channels, it has efficient packet aggregation, higher density symbols. What's going on with 11ax? What's the top? Give us a quick summary. And we have talked about this in a previous webcast. We don't go into too much detail, but tell me what's list off the top 1, 2, or 3 features of AX. That's some big improvements.
So first you have OFDMA, which allows multiple access, right, from multiple clients, which really you had downward to multiple clients in AC, but you didn't really have upward to multiple clients. And whereas 802.11ax takes care of that issue of allowing for that bidirectional capability, right? So that was going to reduce some of our latency issues and some of our contention issues, and just overall, airtime utilization. That's one really big key thing. The other thing that AC didn't really do, or when it does well, but I mean it's not going to do as well as AX is. Now we got density, right? I mean stadiums, large deployments. How do we take care of that near far problem? Where if I'm a client at an edge where I hear my AP, but then I can hear that guy that's a little bit further away communicate, well, I got to stop. I can't talk, right? So, well, we got those resource units, got the OFDMA. Well, what are we going to do about this? Well, we come up with this idea of a color code, which is really just a number associated with a particular AP. So that way it puts it in its beaconing and its transmit. So that way I know that I'm going to pay attention to you. Because when clients are broadcasting to an AP at the same time, they're not really interfering with each other, right? Because when I broadcast, I could care less what you're broadcasting. My AP has to worry about if it can hear the other broadcast. So I mean, now I'm opening that up in the sense of I'm able to handle more clients, more packets, more just in general, more communication cycles from a network, from a cell size of that particular AP. So I mean that's a big key kicker between the AX and the AC is just that alone, allowing for that capability between the color code and the OFDMA.
Okay. Yeah. Okay.
Yeah. There's
Yeah. So these things are all around this aspect of making it more efficient, right? That's what it's all about. And so let's map that a little bit, that efficiency into the applications and how things have changed in the last, 3, 4, 5, 6 years, 5, 10 years. So we've had, if you go back historically, you look at, tablets started in 2010, with the iPad. Now everybody's got a tablet, and tablets have, for a while there, they thought tablets were going to, kick laptops out of business, put them out of business. Laptops have come back. Right? Laptops are stronger than ever. And so now we have laptops, we have tablets in the network, we have smartphones. Those are different types of devices we have. They're all contending for access. And then we have 2 other aspects that really impact the network, 2 other things to talk about. One is the always connected social media, right? So social media used to be something you checked once a week, twice a week, then it was every day, then it was a few times a day. And now it's always on. It's a 24-hour-a-day cycle, right? The news cycle and social media with TikTok and Twitter and your Facebook feeds and all the different things that might that might impact us. We're on the WhatsApp groups. It's a constant barrage of 24/7 social media presence. That creates potential for contention. It's an application that needs to be accessible. Other thing is streaming media, streaming multimedia, and think about the last time you traveled in a hotel. Did you stream Netflix or HBO Go or something else? You probably did. You probably did in your hotel. So now we have to deal with streaming media at different bit rates. So Wi-Fi 6 has to deal with all of those issues, right? It has to deal with more devices in the network, doing more things than ever before, and sometimes at very small packet sizes. And that's the challenge. And that's how we lead to this concept of higher efficiency. More devices, doing more things, oftentimes very small packet sizes. So that's what's the problem we're trying to solve there with Wi-Fi 6. So Wi-Fi 6, Mitch, where can we use Wi-Fi 6 today? Where's it available?
Basically
Frequency,
available everywhere.
Bands.
Frequency. Well, right now, currently, and soon to be, we have the 2.4 band and the 5 gig band, right?
Okay.
So, which is the Uni 1, Uni 2, Uni 3, and the ISM band. You can even say that some of them break it out into 2A, 2B, because I mean, the 5 gigahertz is not necessarily a contiguous 5 gigahertz. I mean, there's some breaks in there of a frequency that's not been allocated for one reason or another. Or even shared frequency, or the DFS space where you're allowed to do this at, but you have to be able to jump off of a channel whenever you hear possible contention. So, that's where, the Wi-Fi 6 is currently.
That's where it is.
Those bands.
That's where it is. Okay, good. So it's still stuck at 2.4 gigahertz and 5 gigahertz, right there with, with my old printers and, old laptop devices and all sorts of things that we still have, we don't throw away. So that creates a problem, doesn't it?
Yes, it does.
Yeah. And so the idea with Wi-Fi, of course, Wi-Fi as a term is a licensed term. The term Wi-Fi is a license, a trademark of the Wi-Fi Alliance, and it refers to their certification programs, which ostensibly, try to test interoperability between access points and clients. Unfortunately, not all clients are Wi-Fi Alliance certified. A lot of your Apple devices, they're not Wi-Fi Alliance certified. So you have things that aren't necessarily tested to be interoperable, although generally they generally work just fine. Wi-Fi Alliance also tries to showcase backwards compatibility, but again, that doesn't always work exactly the way we want it to work. So we've got a lot of issues to deal with. A lot of reasons why Wi-Fi 6 running in the 2.4 and the 5 gigahertz band is not going to deliver all of the advantages that the protocol offers. It's just not going to do it. We need something else.
You're still using some of that old equipment out there. And you talked about compatibility. Compatibility means close, right? It doesn't mean exact. So thus we come out with a new standard, right? Wi-Fi 6E, right? Whole new frequency band, 1200 megahertz of channel space, a whole green field, kind of like what way back when we brought in 802.11a, which was 5 gigahertz, right? That was kind of a green field, but now we say, okay, look, we've used up that green field. We need some greener pastures here. So, thus we come up with the Wi-Fi 6E.
Why do you call it greenfield?
Because really, truly, you're going to be producing more clients, newer clients that are going to be utilizing that frequency. Current Wi-Fi clients still only operate in that 5 gigahertz and in that 2.4 gigahertz, right? So these older clients, which we've maintained compatibility with, we don't have to be compatible with, because we're now going to a whole new standard, and these new guys are not going to don't have to talk directly with the older generation, right? The 2.4 and the 5 gig. So they're going to get that whole band to themselves. So that's why we call it a greenfield.
Greenfields. So it's brand new frequency allocated to devices that talk in this new 802.11ax protocol. Good. So that's new. That's brand new. So there's already, but 6 gig. Why haven't we used 6 gigahertz yet? I mean, up to this point, why all of a sudden is this the big thing? Is this something that is this 6 gigahertz band? Has it just been sitting there unused, or where did this come from?
Well, the 6 gigahertz band was really used for backhaul for carriers and for enterprise networks, in the sense that if I needed to backhaul from one point to the next, and I couldn't string fiber, those many miles. I'm coming across open territory. I'd set up a point-to-point system and use this 6 gigahertz. It's a great frequency, especially in the outdoor arena, because it's not a subject to the rain fade. It doesn't have oxygen absorption issues. So I mean, very little environmentals will affect a 6 gigahertz link. So it was one of those frequencies that was really well utilized for that capability.
So it's out there. So you're saying that there are devices out there today, microwave, terrestrial links, satellite links, using 6 gigahertz frequencies, right?
Yep, currently
And
6 gigahertz frequencies.
and are those folks licensed? Can we kick them out?
No, unfortunately, they're licensed. It is a licensed area. So
I would not kick them out. That's I'm just being facetious. I wouldn't even think of it. But actually, that's a good point, though. We have to address that point, right? The number one thing consideration here with Wi-Fi 6E, we all want to acknowledge and pay attention to. The rules around Wi-Fi 6E protect the incumbent users of that spectrum. And that's a
correct.
very, very, very important thing to consider and remember, that the governmental regulators that are looking at utilizing this spectrum, they're looking at ways to allow Wi-Fi to use 6 gigahertz, but in a way that does not interfere with the incumbent licensed users. And so that's a key thing. So there's going to be this new thing called AFC, automatic frequency control. And that's going to be the mechanism that we use to protect these incumbent users. And basically, I'll give you a quick summary of what the AFC is. AFC is going to be, it's a system that sits between the regulatory domains. So you have the regulatory domain. In the United States, it's the FCC. And the FCC in the United States, they maintain the list geographically of where these licensed users are, what frequencies they use in the 6 gigahertz band, and what power levels they transmit at by geography. And so they maintain that database. And then on the other hand, we have these new Wi-Fi 6E devices that want to utilize some of that space. And so AFC sits between those two. It talks to the regulatory domains list of devices and geographies and power levels and frequencies. And then it allocates to the access point what it can do. It allocates a set of frequencies. It allocates the transmit power levels such that they can utilize the same parts of that 6 gigahertz band without interfering with the incumbent users. That's what AFC is. So it's going to be a nice new technology that's coming out. Let's talk about the status of that. So right at the moment, there are no AFC standard. There is not an AFC standard published by the regulatory domains as of today, as of this recording. The US FCC was the first global domain to issue some rules, and I believe May 2020, but they mentioned AFC, but they did not outline how the systems would work. Now, they are still collecting and still analyzing some feedback from different companies as to how AFC could be deployed. And we do expect the FCC to issue some rulings probably in 6 months or so, some rulings about how AFC systems will be built. But the interesting thing, Mitch, is that the market does not like a void.
No, it does not. Doesn't want to wait. Nobody wants to wait. That's why we've got fast food. Nobody wants to wait for anything.
That's exactly right. So we're gonna get the drive-through window of AFC systems, and that could be a good thing. That could be a bad thing, right? You don't want a lot of systems out there that are just slinging some bad French fries. You want to make sure that our AFC systems are compatible and follow a standard. So a lot of work is going into that, and a lot of changes are going to happen really quickly in 2022 as the FCC gets closer to releasing their AFC rules. they'll be working with these companies. And today there are some consortiums that are working on open AFC, which should be some systems to provide the core of an AFC system, so that Wi-Fi vendors, can actually develop maybe their own AFC systems using a common core, a common protocol, and common set of APIs. And there's some other systems out there that are also very promising on the commercial aspects of AFC. So I think that it's going to happen very quickly. So AFC, pin that one up there for a minute. We're going to come back and talk about that in a minute. You also talked about the 1200 megahertz of new spectrum. So how does that compare? So in the 5 gigahertz band, which today has been the best band that we have, 5 gigahertz. In 5 gigahertz, what do we have, Mitchell? Just rough numbers. How much frequency approximately?
Rough numbers. So I want to say it's like what, somewhere around 500 megahertz of bandwidth, 600 megahertz bandwidth. And we can break those into channels, right? 20 megahertz channels, 40 megahertz channels, and 80 megahertz channels, and some, 1 or 2 160 megahertz channels, right? Well, you just heard, but there's only so much bandwidth there. And so when you start looking at the number 20 megahertz channels, you're at about 20, 24. 80 megahertz channels, you're somewhere around 15, 16, and then the 160, you're at 2. Well, that's kind of limiting. Doesn't really allow a lot of reuse for those higher bandwidths, right? So I could push those higher throughputs down to the clients, right? Because whenever I push that higher throughput, that means that client can regurgitate what it wants to regurgitate through that whole bandwidth and get off and move on, right? If I have to have a really long conversation over a smaller bandwidth, I'm going to eat up that airtime. So we want to get those bandwidths wider. So now we have this 1200 megahertz, which is going to allow us to have as many 80 gigahertz channels as we have 20 megahertz channels in the 5 gig, right? And then we're going to have like as many 16 or 160 megahertz channels as we do 80 megahertz channels. So I mean, we're doubling the capability of the Wi-Fi just by having that larger band.
Okay, so going from 500 to 1200, that's over double. That's
right.
But even of the 500 you mentioned in the 5 gigahertz, a big chunk of that is controlled, the access to about 300 megahertz of the 500. So 3/5 of it is locked up in DFS access rules.
Exactly.
So yeah. So how does that impact your numbers now?
Well, I mean, if I'm a shared space, right? DFS, that's really what it is. If I hear somebody broadcast that's not necessarily a Wi-Fi, I have to move channels because it's used by other things. One of the big things that it's used by is Doppler radar. So if I hear a Doppler radar signal, I got to move. So, and in some ways, it's a useful, unuseful band, right? I could use it. I mean, even some of the low-end clients don't even talk on the DFS band. Right. So I mean, it's there, but it's not there, right?
Yeah, good point. Yeah, it just, the access rules makes it very difficult. So now if you take out that 300 and call it, say you have 180 to 200 left over, and you're going to go from, let's say, 200 to 1200, that's now a 6-fold increase of very usable contiguous spectrum. And that's why the 1200 megahertz of spectrum is oftentimes the #1 thing you see when people talk about Wi-Fi 6E. They always talk about 1200 megahertz of new spectrum, the greatest expansion since 1999. And it is. It's actually true. But there's always a catch, right?
Well, you got to have some rules, right?
Yeah, you want rules? We don't need a stinking rule.
Yeah, rules are for the other guy, right? But no, seriously, you're going to have some rules, right? So I mean, we're going to have to, you already talked about one of the rules, AFC, right? Because we don't want to, contend with people already utilizing the space. Then you're going to have power restrictions, right? Depending on where you're at and what you're doing. As well as whether it's indoor or outdoor use, right? Because if I'm outdoor use, I am more likely going to have the possibility to interfere with one of those people that are using that outside the band, outside area for point-to-point communications, or the news companies using it to stream back to their news office for them to report live on site, or or even satellite, right? So those guys definitely need to have that AFC, so this way that we don't interfere with each other and basically give everybody a bad experience.
Yeah.
But indoors, we got power constraints to help us not to overstep our area, right? And not necessarily interfere with those incumbents.
Okay, so let's talk about the rules a little bit. And we did talk about AFC. Let's put AFC into its proper location. So there are three classes of product, three classes of a wireless network that are identified and defined for use in the new 6 gigahertz band. There's now three classes. So we need to pay attention to all three of them. Each one has its own set of rules and operating parameters. So the first one is called VLP, which stands for very low power. And that is exactly as it sounds. The maximum allowed transmit power there is going to be 14 dBm. That's VLP. Currently, United States, FCC has not ruled that that's allowed. Other regulatory domains around the world have actually opened up and said, yes, we allow VLP. In fact, some of them have said we allow VLP 14 dBm indoors or outdoors. That's pretty common around the world, not in the United States, not in the US FCC domain. The other one, the middle one, is called LPI, and that stands for low power indoor, So it kind of, the name right there tells you all you need to know. It's indoor only. It's not allowed to be used outdoors. And so there's rules about that. If you're going to operate an LPI, you can't build an external antenna. You cannot have external antenna connectors because they don't want you to be able to connect up a more powerful antenna using it outdoors. It cannot be built into an outdoor environmentally hardened enclosure. Again, trying to limit the use of that LPI to indoor only. So there's rules about it, right? Rules about the product design. Now, LPI theoretically allows up to, well, not theoretically, it does allow up to 30 dBm if you're operating on a 320 megahertz wide channel. So I'll leave it right there. We'll come back and talk about that later. That statement is pretty powerful, and there's a lot more detail involved in LPI, which we're going to drill into a bit later. The third class is SP, standard power, SP. Now, standard power is what we are most familiar with. It's the power levels that we've used with the 5 gigahertz. It's the power levels we've used in 2.4 gigahertz band. It is up to 36 dBm, EIRP. So up to 36 dBm, starting on a 20 megahertz wide channel. So SP, wow, that sounds like what I want to use. Forget about this, LPI and VLP. I want to use SP, and SP can be indoor or outdoor. That's the good news. But we're talking about rules. Different rules apply. So in order to use those SP power levels up to 36 dBm, you have to be supported by an AFC system, automatic frequency control. So that AP, what channel it can use, what frequencies it can use, and what power levels it can use per geography is controlled by an external device. So you do not have control of the frequency, the exact frequency and power levels of the SP class. It is under control of that AFC system. So different rules for different different types of deployments. All right, so we're going to, Mitch, we're going to take a pause here. Okay. We're going to say this is it for this webcast. And what we're going to do is we're going to pick this up later, because I really want to invite you back, Mitch, and I want to spend more time talking with you about LPI, low power indoor. And so I think next time, Mitch, when I get you back and you get a chance to join us again, we're going to talk about low power indoor rules and some of the numbers that define those rules, and when can you use 30 dBm, and we're going to talk about how that impacts the network design. That sound like a good topic?
Sounds like an excellent topic.
It does. So Mitch, all that stuff that you normally used to do, You think you can do it in your sleep? Well, guess what? You're gonna have to open your eyes up now, buddy, because you won't be able to do it in your sleep anymore.
No, you won't.
Wi-Fi 6E will change the way you design and deploy your network, and we're going to talk about that in our next webcast. Thank you all for
Excellent.
joining us, and come back again soon.